One of the really powerful things about using vectors in a kind of mathematical way to help us solve problems in physics is that you can break down any vector into its components, which are usually components in the direction of two perpendicular axes. So what does that mean? Well, we can consider a vector, say a velocity vector, which is going in this direction here, and let's call that vector A. Why not? And you can see, just say this was on a grid of north, south, east, west. You can see that some of that motion, although the motion is in this direction to the northeast, that you can kind of think of it that part of that motion is going to the east and part of that motion is taking the object north. So the object is traveling north as well as east, and we can break that down and look at that mathematically. So let's just get rid of this the north, east, south and west for the moment, and let's just label these axes y and x because it's kind of familiar. This angle here will be theta, and you can see that this vector has a component in the y direction, so however quickly it's moving in the y direction, so see where that lines up, and it has a component in the in the x direction and in the y direction. And you can just use some simple trigonometry to find out what the size of those components are. So here we go. The x component, let's call it ax, equals a cos theta, and the y component ay is a sine theta. And you can just see that from doing some simple trigonometry. Now, just to note here that the components, or the angle, is actually measured from the positive x-axis. And so you have to start at the x-axis and measure around. Just show that there. Start at the x-axis and measure around this way to measure out theta. But you know what? Even knowing this statement here that x is measured from the positive, theta is measured from the positive x-axis, you just need to use your common sense to see if your the values you're calculating actually make sense. Ooh, and look, that becomes particularly important when you have, say, a vector down in this quadrant here, which is pointing into the negative parts of the y and x, or even negative of one of those components, that you can have components that are negative. And you see here that this one would have a y component heading down this direction here, and would have an x component going over here. Just for completeness, we can work out that the magnitude, what the magnitude of that vector A is in terms of its components, and we use Pythagoras' theorem for that. Oh, and I really should have noted here that this is a y and this is a x. So using Pythagoras' theorem, we know that the size of the vector A is just the square root of ax squared plus ay squared. See if this looks familiar to you. And you can fiddle around with your original equations for the components size here, and you can find an expression for theta. Again, that's just using some basic trigonometry. One more really small point is that, or maybe not such a small point, is that the vector sum of these components, so if we added ax top to tail with ay, look what we'd get. They'd add up to form the vector A. Another quick note is that these axes don't always have to be drawn in this manner. They don't have to be a vertical and a horizontal line. They can be drawn however helps you to solve a problem. So if you're talking about an inclined, like a ramp, your axes might be tilted to line up with that ramp. And we'll get to some more of those more complicated problems in class. Oh, I almost forgot. We can write a vector A as a function of its two components. There's some special notation we can use. And writing it like this can be particularly useful when you want to add vectors together. So we could write another vector B. And if we wanted to find A plus B, it works out pretty easily. For the x component, we just add the two x components. And for the y components, we just add the two y components. Easy. Hopefully, I'll just make this look like the other y. Hopefully this will become clearer to you once we do some more work of this type in class.